Now we're going to look at the equation have multivariable with the rational uh, expressions involved. Right? So if you can see, in this case, we are particularly asking you to solve for y. So since these equations contain fractions, like in previous example, we're going to multiply by LCD to clear the fractions. In this case, my LCD is x minus 4. So we're going to multiply the left hand side by x minus 4 and then the right hand side by x minus 4. Or you can use the cross product method idea. M equal to y minus 5 over x minus 4. So on the right hand side, when you multiply by x minus 4, they cancel, they reduce it, so you're left with y minus 5. On the left hand side, when you distribute m, that will become m times x minus 4 times m. And we are solving for y, so I add 5 to both sides. That gives me my final answer, which is y equal to mx minus 4m plus 5. Moving on to the next example. So in this rational equation, we are solving for a. So my LCD in this case is a, b, c from all those fractions. So I multiply the left hand side by a, b, c and the right hand side by a, b, c. So this will be 1 over a plus 1 over b, 1 over c. So when I distribute this ABC to the first term, A and A cancels it out, so I will left with BC. Distributed to the second term, that will left with B and B cancels it out, so that will left with AC times 1. Equal to, when I multiply on the right hand side, C and C cancels it out, so it will left with AB. We are solving for the variable A, and I noticed that the variable A is on left hand side and also the right hand side. So what we need to do is we need to move all the term that involve the variable a. Meaning, in this case, I'm going to be subtracting AC to both sides. Now I have all the variable a, all the term that involving variable a on one side already. So to solve for a, first I need to factor a out. So that we're left with b minus c. Now that it become a product, I can divide both sides by the binomial b minus c. So a lot of times we are stuck on this step, okay, because we forgot to move everything to one side, all the variable that has a move to one side and a factor. Okay. Next, and this example is to help you to recall the terminology, the function notation that we learned before. So if we are interested in looking for the domain of the functions, since this is a rational functions, we know that the denominator cannot be equal to 0. So my part A, to find out what is my domain, I need to first look for the restrictions. So denominator cannot be equal to what? 0, which another way of saying is which x value will make this whole fraction undefined. So in this case, my denominator is x squared minus 7x plus 12 cannot be equal to 0. So I factor it out, which is going to be x and 12, so it'll be minus 3 and minus 4. So now I can say that x minus 3 cannot be 0 and x minus 4 cannot be equal to 0. So we got 2x value cannot be a part of the domain. So if you substitute 3 and then if you substitute 4, you will see that the whole entire fraction will become undefined. So my domain is anything except those two numbers. So in set builder notation, it will be a set of x such that x is all real number except x cannot be equal to 3 and x cannot be equal to 4. Or in interval notations, we write it down. Remember, we did this before. Here's 3 and here's 4. Both of them is open circle and then everything else is fine. So you can visualize this one first and you can write it down. Interval notation will be a negative smallest value to the largest value. So it will be negative infinity to 3, not inclusive. And the middle portion will be 3 to 4, not inclusive. So 4 to infinity, not inclusive 4. And then all together, so union. So that is part A, finding the domain of function. Part B is basically asking for what is the value of x, find the value of x when f of x is equal to 3. So when f of x is equal to 3, this f of x is basically talking about my y. So another way of saying is when my y is 3, what is my x value? So we can start with f of x is equal to 3, and we know that f of x, the formula for it is 8 minus x over x squared minus 7x plus 12 equal to 3. And we already factored this out already earlier, so we can just basically say that this will be x minus, in the denominator will be x minus 3 and x minus 4. So solving this rational equations, we multiply both sides by LCD, right? Clear the fraction. So in this case, my LCD is x minus 3 and then x minus 4. And also we know the restriction x cannot be equal to 3 and then x cannot be equal to 4. So now multiplying the left hand side and the right hand side by x minus 3, x minus 4. 8 minus x over x minus 3, x minus 4, and then on the right hand side is 3. So the left hand side we reduced it, so x, we're left with 8 minus x. And on the right hand side we are multiplying 3 times, which when we multiply back it will be x squared minus 7x plus 12. And distributing this 3 into it, that will become 3x squared minus 21x plus 36. Solving quadratic equations, so first I'm going to be adding x to both sides. That'll give me 20x. And then subtracting 8 to both sides, that'll become positive 28. So now, factoring this out, you can use the trick that I taught you. So let's review on that trick, right? So a times c, right? Remember, this is going to be a little bit tougher because again the number will be very large number. A times c, which is 3 times 28, that give us 84, positive 84, and then we want negative 20, and we want to find out which two number will multiply and get 84 and then add it up to get negative 20. So I can basically try this. 84 divided by 4, that is basically 24 times 21, right? That's not going to give us like added up to give us negative 20, so I need to make it a little bit larger. So 84, I'm going to divide it by 6, so that will give me 6 times 14. So now we know that it will be negative 6 and negative 14, and then we need to divide it by the leading the a part and then reduce it. So 3 goes in one time, 3 goes in 6 two times. So my factor in this case will become x minus 2 and then 3x minus 14. So using zero factor property, I can split it into two cases. So x is equal to 2 and then 3x is equal to 14 and x is equal to 14 over 3. Now checking, and since none of these values are my restrictions, right, so that I can say that my final answer will be 2 and 14 over 3. Those are the x value going to give f of x equal to 3. And this will end our session.